Okay, in the last lecture we had what is a tone, what makes up a tone, and what is a noise. We perceive things that are musical because they have a regular periodicity, like our heartbeat, like our respiration, like like the moon and the sun. So today we're going to go with different types of sounds and different types of musical instruments. We're going to cover these 5 types of musical sound generators. And what are we talking about as far as sound? Is it a thin sound? Is it a thick sound? Is it a quacky sound? Is it a noisy, hissy sound? And how do you make it happen? Is it a harmonic sound, which is the subdivision of the string that I covered last time? Or is it enharmonic, meaning that there are harmonics and overtones that are not related to a fundamental pitch? Yes, those happen. Is it monophonic? Is it polyphonic? Can you play more than one note, or is it one note at a time? So, first of all, the 5 types of instruments. An aerophone is a clarinet, trumpet, a harmonica would be an example of a polyphonic aerophone. You blow through reeds like on a harmonica. Like on a saxophone or a clarinet, but you're blowing into it and you're using the keyboard, which is each has a little reed of that pitch. Same as a harmonium, which is the pump keyboard, and same as an accordion. So, aerophone. You have like a flute. That German flute is the metal flute, and it has a conic bore. It's so high up, like I said in the last lecture, that it has to have a conic bore to squish out these higher harmonics that are normally so high that you can't perceive them. But it's a whistle sound, so if you don't get those high whistling sounds in, you wouldn't even be able to tell that it was a tone to begin with. Clarinet is an open sound, not a thick sound, but a thin sound. It's only the consonant harmonics because it has a cylindrical bore. A trumpet has a conic bore, a saxophone has a conic bore. You blow with your lips vibrating onto a trumpet or trombone mouthpiece, French horn mouthpiece, and you blow through a reed on a clarinet saxophone, which is a small piece of cane. And instead of your lips wiggling back and forth, it's the cane wiggling back and forth, which gives you your tone. A pipe organ is an aerophone. You blow through pieces of metal attached to the pipes, I think. Or it could be reeds. Either way, it's a keyboard, but it's still an organ. Still an aerophone. Chordophone is a string. Guitar, violin, string bass, cello, etc. Pianos, you're striking strings with a hammer, so that's kind of a cross between an idiophone and a chordophone, because you also have the idiosyncratic sound of the hammer hitting the strings, and the action, which is a little wooden kind of lever. Idiophone, that means it's idiomatic, it's idiosyncratic. It's like if you hit a stone, you get a tink tink, and that's just the sound of the stone. A cymbal, or a metal percussion instrument. A cymbal is an example of, or a bell is an example of an enharmonic sound. You have all these little sympathetic vibrations coming out that are not related to a single tone, like you would with a trumpet, like you would with a string, like you would with a synthesizer even. Membranophone, drums, anything you stretch out and hit, and it makes a sound, a tone of some kind. Snare drum, you have these little you have like a metal wiggly wires underneath the drum, and that noise, you could call that an idiophone or a membranophone, because you have that metal slapping against the drum head, the stretched membrane, and you get that noisy psh. And then electronic instruments, there are basically 3 types of synthesizers. So you can have a mechanical generation of sound, which could be either blowing air through a reed or percussion on a mechanical motor. But synthesizers, there are 3 kinds. Voltage controlled synthesizers, so VCO, that means voltage controlled oscillator. The keyboard each key has a certain voltage which generates the pitch, and it is rectified by the oscillator. That just means wave maker. Pulse code modulation is the second type of electronic instrument. That was the digital synthesizer in the 80s and 90s. digital technology was kind of low bit rate, low resolution, low density, low computing power. So PCM, let's just say this is your pulse. So like a square wave, you have beep and you have boop and you have beep and you have boop, and they go beep 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 boop boop boop, and that together makes your tone like a buzz, and it's a buzzy sound. And because it doesn't have the top of the curve, it's chopped off, right, like in the last video. So you get a kind of buzzing, you don't get the harmonics at the top, and you don't get the pure harmonics because there isn't like that curve to support that regular vibration, to support the curve that is kind of self stretching and releasing. Now, what you did in the 80s, when like the Yamaha DX7 was that thing with didn't have knobs, it had just these little flat membrane switches, and that killed the analog synthesizer overnight because you could get realistic enharmonic sounds, the sound of a bell, which is a complex sound, the sound of a piano, which is a complex sound. And you use what's called frequency modulation. So let's just say if this is your boop, boop, boop tone, you have boop, 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 and then you interpolate boop, beep, boop, beep, boop, beep, boop, beep. And that, depending on the modulation, so here's one wave, the big dots, and here's another wave, the little dots. And depending on the combination of those, you can get those enharmonic sounds, like in a bell, like in a piano, the weird kind of twinkly sound of a piano, which is like a combination of the hammer hitting the string, and of course with the piano you've got 2 or 3 strings, so it's could be kind of a mess of frequencies. Now, how about monophonic sounds, polyphonic sounds? Aerophone, trumpet, saxophone, clarinet, you can only blow one note at a time. Harmonica, harmonium, the keyboard, or the accordion are polyphonic. You can play many notes. Strings, you can play as many notes as you have strings. So guitar 6 notes, cello 5 notes, violin 4 notes. Idiophones, I would say if you hit a cowbell, that's pretty much one sound. You hit a rock, that's one sound. So I would say idiophones are kind of monophonic as it is, because for one, they don't really some of them don't generate a tone. They generate like a weird little kind of noisy sound. Membranophones also, I don't know how you could get a chord off of one skin, so I would say those are kind of generally monophonic too. So you'll see in techno music and in disco music and R&B music and African music, you have for the most part a lot of monophonic instruments, drums, and you have a whole lot of them. Gamelan, for example, those bells are a huge complicated mess of harmonics, and you have so many of them that you switch off people hitting each one with the hammer on their beat, and you get this big sound, but there's still one kind of main pitch each. So I would say those sounds, when you use a drum machine, you're not talking about chords, you're talking about single sounds like percussion. So that's kind of something idiomatic to percussion and to rhythm music. Electronic music, the VCO, you need a voltage controlled oscillator for each voice. So if you only have 1 or 2, you might be able to have a chord of 2 notes, but usually it's just 1. The PCM has a different way of, you don't need 1 voice per key. Well, I guess I'm not really sure how that happens. I'll drop that. And then modeling, the third time that I didn't get to yet, that's a much more dense amount of information, and of course the memory is a lot more than it used to be. The computing power is much more than it used to be. So around 2000, the analog modeling synthesizers, those, you're not stuck with what a VCO can do. You're not stuck with what a wavetable can do. You've got a whole lot more power, and you can play polyphonic. You basically just have a microchip central processor that puts out as many notes as you want, depending. So those are kind of like, this is like analog VCO. You have point-to-point resistors rectifying that wave. PCM, you have a carrier vibration, a carrier wave, and then you modulate it and you can change it. And then modeling, it's like, you know, you can pretty much draw a wave with a pen and it'll play it, because we got so much computing power that, you know, you can your computer, the computer making the sound, you can change it and layer it very quickly in real time, and then it's transduced out of a speaker, and it's all kind of at line volume. You're not hearing like a tube amp where you're hearing these overloaded high voltage tubes. It's not a voltage controlled synthesizer where you're hearing actual hot circuits. Okay, so where does that leave us now? Thick sounds, thin sounds. I covered that kind of in the last one. Your sine tone on a synthesizer is like a clarinet. It's perfectly thin. However, a clarinet also has kind of the noise of your breath moving the reed. A square wave, as we discussed last time, or as I discussed last time, has the kind of distortion, the kind of fuzzy sound. And then membranophones, I think, you know, usually a timpani, a drum is a pretty pure sound, depending. And then idiophone electronic is kind of like, and chordophone, you can have thin sounds, you can have thick sounds. Electric instruments, of course, you plug in and you play ba, da, da, the first three harmonics, and it doesn't sound like three notes. It just sounds, when you turn it all the way up, the amp, it crunches it into like one single sound, gong, right? So anyway, hope that helps. And any questions, feel free. Thanks so much.